for you to be able to have something like a variable that can contain or represent a newly created node that won't affect, okay, the value or the status of the head and the current. Going back to the code, these three are the minimum requirements to create a linked list. Now, I have here my main method, and my main method uses recursion. Recursion is the technique of trying to call a function that calls itself. Here we are calling this the same function here. So this function now, this menu can add, show, insert, delete, and edit, except for the last one, which is edit. The first 5 already works, and I already have sent the code to your email. Okay, so since the option is an integer and there's not much code that I have in here, then I would rather have the switch to have what we call as the option for decision making instead of the if else. In this way, it would be cleaner and it would be easy to read. Now, what happens when we are going to add a node? Okay, what happens when we are going to add a node? When we are going to add a node, here I have declared an integer and I named it as item data. First, print, enter the data of the node, then you get it as an item data. Then afterwards, you create the node using that particular data, and this is it. And since it is the first, it is a newly created node, of course, it points to nowhere, and that is why it is null. Okay, and that's why it is null. Now, okay, so assuming we're going to create the node now, okay, we're going to create the node, and this is the node. Let us have a value of 1, and it points to nowhere. So that nowhere means its value is its value is null. If the head is equals to null, which means that there are no existing node as of the moment, we are going to equate temp to the head, and actually here also we are going to equate the head or the temp to the current. So what's going to happen? These three variables, the head, the temp, and the current, all represents the first created node. Okay, it represents the first created node. So therefore this particular node is represented by the head, the current, and the last one is the temp, because it's the first one. Okay, it's the first one. Now, if it's not null, which means that it's not the first one, what we have here is that current next is equals to temp. Okay, assuming we're going to create another one. So this is what was executed on the first entry. Then we're going to create another one. When we create another one, what's going to happen is something like this. We're going to create another node, give it a value of 2. Of course, this points to null. And this one, okay, which is as of the moment equal to null. This one now, this temp will not be here anymore because this is not the temp now. This is already the temp. Okay, this is already the temp. And since current is represents this particular node, current next, okay? Current next, according to the code, it says current next is equal to temp. So therefore, when current next is equals to temp, therefore it is tantamount to saying that this particular, okay, that this particular node now, okay, points to temp by the virtue of the code that says, okay, let me try to copy this, put it somewhere here, okay, that says current next is equals to temp. So that's why current next now is equals to temp. That is the second time we created the node. Then current is equals to current next. So what's going to happen? After setting the value of next to the address of this particular node, current, which is currently representing this node, is now going to be representing this node together with the temp. By the virtue of this particular code, current is equals to current next. And that is how you insert, that is how you add the node. If you're going to add another one, then the same process is going to happen. And since we lose spaces there anymore, we create another node here. And when we create the new node here, this temp, okay, this is going to be represented by temp. Okay, now current next is equals to temp, so therefore this, okay, this particular next will not be here anymore, but this is actually pointing to this node. Okay, pointing to that node. And current this time, okay, and current will also be somewhere here. And then let's try to represent this value as 3. And then if you are going to add another one, then that's going to be the process. It's going to continue following the same process as we add a new node. Okay? Okay. So, if you're going to ask, should the current be always be at the last one? I would say yes. It should always be at the last one. Why? Because if it's not on the last one, where do you suggest it should be? Should it be on the head? And what if you add another node? What's going to happen? What do you think is going to happen if you're going to add another node? If current is not at the end node and you add another node, remember that when you create a node, you need somebody to hold it. And that would be temp. Okay, that would be the temp. And if temp is transferred here, say for example, your current is not at the last part. So say for example, it is together with the head. Then your current should traverse and find a node that points to null. Because the node that points to null is the last node in your list. And then when it's already there, that's the only time then that you can use current next is equals to temp and current is equals to current next. Before I proceed, do you have any questions on the process of adding a node? Okay. Good. Let's proceed. Look at the code. Is there anything on the code that you would like to ask why it is like that? That's the whole code for the add node. Okay, so I bet you don't have any questions, right? Okay, so let me proceed again. So if adding a node is not that difficult, okay? If adding a node is not that difficult, would printing the node be difficult? Let me tell you, it's much easier because this is the code for printing all the members, all the nodes in the linked list. I have here a variable node count, which is equal to 0. And this is just a label. And this is the most noteworthy. Notice here that after adding, actually the current variable, which represents the last node, is set back to the beginning of the head. I mean, beginning of the node, which is the head. So when you're going to display, move this one back to this place. Okay? Why do you have to move that one back to that place? Because this current is the one who would be moving from one node to the next, to the next. This will be the node that would be moving from one node to the other. You cannot ask the head to do that. Because when you ask the head to do that, as soon as it moves to the other node, then the previous one is lost. Here. In here, it's just another thing that you're just going to say, telling us the node, okay? The address, the count of the node count, and the current data. So it's something like the location of the node, okay? So this is now my while loop. This while loop actually just moves as it rotates, as it iterates. Current is equals to current next actually moves. This is the one responsible for moving, just like this one. If you say current next, a current, okay, is equals to current next, okay? So therefore, this current now is moved to that one, to that location. Then you say again, current is equals to current next, then it is moved to this location again. And notice that during the movement, okay, the node count is incremented to appropriate, and then the node data is also printed, and that is the data there. If I'm going to run this program, this is going to look like this. Action 1, data is 1. Add another 1, make it 2. Add another 1, give the value of 3. This time we're going to print the value, all the value. Then if I press 2, it says list content. This is the content of the node. At the node 0, there is 1. At node 1, there is 2. And node 2, there is 3. So this one effectively moves from the head. Okay? Actually, it was assigned to the head. Moves from the head by the virtue of line number 172, and then while moving, it is printed, and it stops when current next is now equal to null. It stops. Why? It means that that part now is the last part of your list, and there's no more node following after that, and that is the end of your list. Do you have any question on this particular code? Okay, so no question so far.
Sir, can you repeat line 170? Sorry.
Line
170, sir.
170. If you notice line 170 and line 174, they're just the same. Before I went through iteration, what I did was just print the head node first.
Okay, sir. Gets ko na.
Okay, before I went inside. Because I could not find a way from which when I'm going to iterate, the head node could be included inside the one statement. When I'm trying to do it, sa una-una ko ba? Saon ka inako nga bubutang baka kog if else, additional if else sa akong loop, or ibutang na nako siya gawas. Actually guys, if you can find a way on how to do it simpler than this, that you can just put it as part of the loop na lang, show your code to me please. I did not find a way to do it, but maybe I'm just too lazy to think of a way to do it. But if you can find a way to do it, mao siguro na nangutana ka na ako, Nico, because you would say, nganong i-print pa man ako ang pinakauna nga node? Nganong dili naman ako iso diritso? Yun na ang mga pangutana ba? Dili na ako makita na pamaagi. Okay, but if ever you would be able to do that, if not now, maybe next year, or maybe next sem, maybe 2 sems from now, I would still appreciate you sharing it to me. Okay? I would still appreciate you sharing it to me. Okay. Bisag nagtrabaho na mo. Sige, pero sige lang ako ni suway pamalandong pud ka nang matugan ni kung di ko katulgon. Magpiyong lang ko. Padagan-daganon ako ang code sa akong utok, di ba? Doka diretso. Basig during that time, ako rin po makita na ako solution ba? But just in case din ako makita ng solution, you sharing to me would really be greatly appreciated. Okay, the next part is the insertion of the node. But before we do the insertion of the node, I'd like to discuss first the deletion of the node. The deletion of the node is a little bit the same as with the printing of the node. Only this time that a certain node is deleted or is freed from your memory. This time I have two variables, the node count and the location. Here I'm asking for the location of the node. Of course, when I'm going to delete a node, then I'm going to ask, which of the nodes would you like to delete? So according to the output, there is a label of the node here, node 0, 1, 2. So if I would like to delete node 1, then I would just say, what's your action? Then I would say 4. Then it's going to enter the location of the node. Then I would say 1. And if I'm going to print it, then there is now 1, 3. The node number 1, which is the value of 2, has been deleted and then the last one has been moved up. So that is 1, 3 na ang content sa akong list. Okay? Now, how is it done? How is deletion done? Here, the same as with the printing, current was, okay, the current was moved to the head. Of course, because if I'm going to delete something and it is only the location that is given, then I would really start from the start. Start from the beginning, so that I can traverse from one node to the other while counting what node is that. That's why I have node count. And node count now is assigned a value of 0. If location that I have entered is equals to 0, it means that I am going to delete the head. To delete the head, notice that I said temp is equals to head. Then head is equals to head next. So which means that your head, currently your head, is assigned, okay, a value, okay, is assigned a value of the next node. This is the next node. So it is assigned to the head. So what actually happens is that your current was actually wait. Let me see. Yeah, your current is actually moved in the beginning. But if, okay, it is actually moved at the beginning. But if location is 0, okay, if location is 0, what's going to happen is that the head, okay, will be assigned to this. But remember a while ago, we have also assigned temp with the value of the head. So temp here is also here. Because after this particular condition, after this condition is satisfied, of course, you're going to neglect the rest. We are going to free temp. Temp here is actually the beginning of the node. Now, actually moving the head to this next node automatically deletes this one. But that deletion does not mean that the memory was freed. It's just that this node is not anymore a part of the linked list or of the list, but it's still there. That's why at the end I said free temp to actually release that portion of your memory to be used by other programs. Okay? Now, what if it's not at the beginning of the node? If it's not at the beginning of the node, this while statement here is the same while statement that you have seen during printing. It iterates until it is still not null. So which means that it will move from the beginning until the end. The only difference is that there is a condition inside that says if node count is equals to location, you break the loop. Okay? You break the loop. And when it means that you already have reached the location from which you would like, the location of the node that you would like to delete. Here, temp next. Okay, where is temp as of the moment? Wait. Is this it? No, here. Temp is equal to current next. Where is temp as of the moment? It doesn't matter where it is. But what matters is that the current, which is moving from one node to the next, is assigning this value, which means the value that would be deleted, to temp. Then you would say current next is equals to current next. How do we all illustrate that one in the diagram? To illustrate that one in the diagram, let me try to remove this part. Copy this one here. Remove this part. and point this one there. Point this one there. Okay. Let me copy the code. Okay. This part. Let me copy the code. But remember that up here, we have said that the current will be equal to head. So works like this. And let's put it somewhere here on the left. Okay, now, if I would like to delete this one, following this code, what's going to happen? Remember that I said a while ago, before we had this one, your head is somewhere here. Okay. And then your temp is nowhere to be found. Okay, that's temp. So as of the moment, the temp, if you just have added something, then for sure your temp is at the end. Okay, this your head is there. And your current is also there. Okay, now. At the beginning, there was current is equals to head. Remember this one. Current is equals to head. So therefore, this current will be moved to that part. This current will be moved. So they are not the same. While current next is not equal to null. So as of the moment, where does current next point to? Current next points to number 2. And you're going to notice that current next, okay, current next is not null because it points to 2. If my input is location number 1, okay, remember that my input is location number 1. What's going to happen? While current next is not equal to null, of course it's not equal to null because it points to 2. It's going to get inside this loop. Node count as of the moment, okay, is equals to 0. And the location that I have inputted is 1. 1 minus 1 is 0. Then therefore, this condition is satisfied. Once this condition is satisfied, this break statement will be executed. And when this break statement will be executed, it's going to get out of the loop. As it moves out of the loop, it says temp is equals to current next. Where is current next? Current next is this location. Okay, remember that this is still the first time that you have entered the loop. So therefore, your current has not left the head. It's still on the head. So when we say temp is equals to current next, it means that your temp is now referring to this particular node. And then current next, this address here, will not anymore be pointing to this because it will be pointing to next next. Where is next next? Next next is somewhere there. So therefore, this will not be here anymore. Okay? And at the end, this will be freed. And when this is freed, then this loop, this node, will not be anymore a part of my list. Any questions so far? So no question if you are still there. Are you still there?
Yes, sir.
Oh, can you please raise your hands if you are still there? Bawa ni ron kasi mo raise hand. Bawa na diya. Ha!
Okay, question,
Sak
sir. Di.
sakpan si Nico si Kiray. Bawa na dire.
I'm here, sir. Ano ako question, sir?
Ah, si Nico. Si Nero di si Nero. Sakpan ni si Nero ni Sibat. Okay, sige, sige. Thank you. Si Nero ug si Kier ni Sibat. Sige lang. Tagay chance. Nico, you are raising your hand. You have questions, right? Sige, go ahead.
What if ang location is equal to 2, sir?
If the location is equals to 2, that's pretty interesting. Work ba? Di ba ako suway-suwayan, bi? Okay, let's try to check the code if it works well. The location is 2. Okay, so the input now is... Okay, so the input is 2. Okay, the input is 2. Let me bring back this one here. And let me erase this. Okay. Let's try to check without running the code if it works. If the location is 2, at the first time it gets inside the loop, current is not equal to null. Of course, it's not equal to null because it's pointing here. If node count, which is 0 initially this was 0, and the location is equals to 2. So node count is equal to 2 minus 1? No, because 0 is not equal to 1. So you proceed. When you proceed, you said current is equals to current next. Therefore, your current is somewhere here. Then node count plus plus. Then therefore, your node count is not anymore equal to 0, but your node count now is equals to 1. If node count is equal to 2 minus 1, which is correct, the answer there is true. Because 2 minus 1 is 1. If 1 is equals to 1, you are going to call break. Okay, you're going to execute break. So you leave the loop, proceed with this. Temp now is equals to current next. So therefore, this temp is already here. Because current next is actually this one. Then current next is equals to current next. And if you're going to notice, current next is non-existent. So therefore, current next now will be equal to null. So therefore, this current now will be pointing to, okay, will not be anymore be pointing to this, but will be pointing to null. And at the end, this one will be freed from your memory. And that is the reason why at the end you have this code, free temp. Okay, let me add another one. Let me add one. Action is 1. Add another data 4. List them. Let's try to delete. Option number 4. Location of the node is 2. You press enter. Show them again. That's 1, 3, 4. The answer is 1, 3. Okay, it works. Do you have any, did I answer? Okay na to, bye?
Oh, okay, ra, sir.
Okay, good. This time we would be inserting a node. After knowing on how to print it and deleting it, this is going to be a lot easier. Here, I've got three variables. That is item data, location, and the node count. Remember that when you're going to insert, you're going to ask for two values. What is the data that you would like to insert? And where would you like to insert it? Are you going to put that one at the beginning, at the end, or somewhere in the middle? So therefore, declaring three variables is actually logical because they are going to hold different values at the same time. So let's do it this way. So here, if the head is equal to null, it means that there's nothing there. That there's no data yet. So we just try to print the number of nodes is equal to 0. This if-else condition is actually a part of the code that notifies the user about the status of the list. Check this out. If I'm going to say insert, and that is number 3, if I press enter, it says there are only 2 nodes and the data at the last is equals to 3. So probably if I'm going to say give me the value 5, and if I would say 10, I would insert it at location 10. That's a little bit illogical. Since there are only 2 nodes, why do you want to insert that one at the 10th node? Then nobody would be able to access it. It's just the same as if you're just going to delete it right after you create it. Do you agree? Do you agree? Isa, tubagal ako ninyo guys. Kaya nindot man ginang natin istorya. Now, thank you, Angelo. High school pala gani dagan na plus points ni si Angelo ba? Di ba? Sa high school na dagang plus points. Sus pag college wa naman gyud plus points oy. Bisag ingnon pa nimo yung maestrong gwapo. Gwapo siya. Di gyapon katagag plus points. Ay kaguol. Now, enter the data of the node and enter the location of the node. After creating the data, after doing this one, these two, we create the node. But notice that the node that was created is not attached to your list yet. It is just a node that was created, but it's not attached anywhere. Now, if location is greater than the node count, just like this one, the location you have is 10 and it's greater than the node count. If location is greater than the node count, add the node at the end. So this is what we do. Print that the location you have selected will insert the data at the end of the list. And then current next is equals to temp, and current is equals to current next. Okay? Current is equals to current next. What does it mean? It's just the same as with this one. Okay, current next is equals to temp because you are adding it at the end of the node. So just like adding it naturally. But if the location is not greater than the node count, which means you're not going to insert it at the end. Else, if location is 0, then temp next is equals to head. What does it mean? It means like this. It's just like creating the node somewhere here and pointing it there and moving the head somewhere here. According to the code, it says temp next. The newly created node will point to the head, and your temp now will become the head. Okay, and your temp now will become the head, and that is what is illustrated here. So what if I am going to insert it not at the beginning, not at the end, but somewhere in the middle? Again, this kind of loop exists again. Because this loop iterates from the beginning to the end. And it stops when the node is equals to the location. When the node is equals to the location, notice this one. The newly created node will be pointing to the current next. Okay? To the current next. And current next will be equal to the temp. What happens? Let me try to copy this code. Let me try to copy this code. I think I was not able to copy everything. Let me try to copy it again. Copy. Then paste. Oh. Oh. Wait, guys. One moment, guys. One moment. One moment. Iuwan ka dyan lang, ha? Ni taligsik. Unya, pag taligsik, nag-uol ko kaya ako mga piso, mabasa. Namo ko'y chicken, guys. Akong chicken, one time gitagaan ko estudyante og usa ka buok chicken. Kaya ako silang giingnan ba nga iguli ninyo sa inyo ha, igbalik ninyo dire. Dad kog something delicacy sa inyo ha. Matay sa ila sigurong lugar, ang ilang mga tao dito sa Bungiro, gidad-an ko niya usa ka buok sunoy. Unya, ang among silingan gitagaan mi og usa ka buok girl nga chicken. Unya, pag naapagid nila ang silingan, gihatagan kog usa ka pair nga chicken. Karon kay 60 na sila kabukapin. Kay di man nimo ihaw kay maluoy mo sa chicken. Kay kisan gud namong chicken. That's it. Actually na ingon ko sa chicken ba nga, chicken pinangga man kanako kaayo pero ikaw akong i-offer ha. So blessing in disguise biya ta ato nga chicken JR. Ikato nga chicken nga akong gi-offer wala giihaw sa mga pari but hindi instead ilang gibuhian dito sa taas. So pag kita na ko niya one time yung kog chuya guni mo chicken dagan kay kog uyab diri. So sa iyang uyab mga tulo or upat ka buok iyang uyab. Nga healthy kayo siya sige dagan-dagan tugpa-tugpa sa mga kahoy yung kog nindot gid ining basta i-offer nimo sa Ginoo kay abi na kog ihawon sus malipayon man kay itong manok dito. Anyway, let me proceed. Naunsa naman ni? Okay, let me try to copy the code again. So here's the code. Okay, so what's going to happen? If I'm going to insert somewhere, okay, I'm going to insert somewhere at this location. Let's say the location is somewhere here. Okay, let me see the location is somewhere here. So when I'm going to the location is somewhere here. So location is, say for example, let me see. So if I'm going to insert it at somewhere location 1, okay, insert 5, 2, so it's 152. So, okay, say assuming we're going to insert at location number 2, which means that I'm going to put it here and I'm going to move this one down there, push it somewhere there. So, this would be the temp that is going to be created. Okay, so this is just going to traverse. The node count starts from 1. Okay, this will be somewhere at location 0, location 1, okay, location 0. Let me call it as location 0, location 0. Okay. Don't worry about the values here. But if it is inserted somewhere here, and if this condition has already been okay, so temp next, remember that this is your temp now. Okay, that this is your temp, okay? And your current, okay, your current is as of the moment somewhere here. So temp next is equals to current next, which means that this temp, which was equal to 5 a while ago, I have inserted 5. This one will also be pointing at the same location from which my current is also pointing to. So current next is pointing to that. Temp next is also pointing to that by the virtue of this particular code. Then current next will not be any more pointing to this, but will be pointing to this. And this connection somewhere here will cease to exist. And that inserts the list, the node somewhere here on your list. Question so far?
None for me, sir.
Okay. Now, what I am leaving for you to, lahi man guna mo sabot lang kabay ba? Lahi nang mo sabot kaysa ikaw gyud mo himo. So karon ang gustong na akong mahitabo is that kamoy himo aning ikalima edit node. So kung mangayo ka sa ikalima i-edit nimong node, how many values do you think you're going to ask if you're going to edit a node? Can you tell me? But you're going to edit it. Probably you're going to ask another one for the new value, right? But before you can change the value of the data, you have to ask for the node. I mean to the location so that you can traverse just like this and stop. Okay? Maybe probably something like this. And stop when you already have reached that node and change the value of that particular node. So this time what you're going to change is not the next, but the data. I'm gonna leave that one to you for you to do that. Okay? So, by the way, how's your project? Okay. If ever you happen to finish earlier, call my attention so that I can check it earlier para mawa na yung problema. And on succeeding meetings, I'm not going to, we're not going to have, online synchronous meeting anymore. I'm gonna leave the rest of the meetings for you to create your project. And also this one, though I'm not going to check that if you already have edited the node, but that's really going to help us later on when we take the final exam. Yes, Joval.
About the final exam, sir, ano sa?
Probably December 10.
Okay, sir.
If not within the final week. How about the rest? Angelo? Finals week. That is December 14 to 8. Wait. November, madinigitan na na to. 12 to 16? Yes, Ker? Nanas, Ker, nibalik na. Ker, you're raising your hand.
Ay, Connor na sir, same ramid question ni Jello.
Okay. Ray?
Sir, pwede mo tanong balik on say like coverage sa final exam, sir. Link list ra ba to, sir? Or
Link list o katong files.
okay, sir. Thank you, sir.
Sige. Did you have doble link list during your ang katong naka-take ani before ba na ba dong doble link list wala?
I think single lang amo, sir. Wala kami nag-double. Single lang.
Okay. Sige. Okay. Okay, kinsa pa tayo na-raise yung hand ganina? Nico?
Ah, wait sir, nakalimot ko sa question na ako.
Anyway, you can shoot me a question with a question on our chat group. If ever you have some questions, and then yeah. Yeah, go ahead, Nico.
Ako answer, are we still gonna use code chum sa finals?
Yes, yes. CodeChum and Canvas.
Okay sir.
Okay. Okay, so if you don't have any more question, let's call it a day. Have your dinner earlier and